We are going to sketch the graph of a function that is continuous on 1, 5, close interval 1, 5, and has absolute maximum at 5, absolute minimum at 2, local maximum at 3, and local minima at 2 and 4. And we have done that here. So we have this graph, and as we can see on this graph, we have a local minimum at 2. This is the lowest point in the graph when we look close to the number 2. But it's also the absolute minimum, because if we look at the whole graph, this is the lowest point. So at 2 we have a local minimum and an absolute minimum. So we have those two parts. We have also local minimum at 4, as was stated here, local minima at 2 and 4. So at 4 we have a local minimum, because if we look close to the number 4, the graph of the function has the lowest value at that point. The same happens around 2. But at 2 we also have the lowest point in the whole graph, and that is the absolute minimum. Now we have a local maximum at 3, and that's the case because at 3 we have this point, and if we look around that point, that is the highest value when we look around, or near the value 3. So we have there a local maximum, but it's not a global maximum, because the global maximum, or the highest point in the graph when we look at the whole domain, happens at this point here, which is 5, as expected following the statement, absolute maximum at 5. And there's neither a maximum nor a minimum at 1. And it's important, the graph of this function is a continuous graph. That is, we don't have any jumps or points detached from the trend of the line. So it's only one piece draw that is a continuous function. So we have this example. This is a way of drawing a function with these properties. Continuous on 1, 5. As here, the domain is 1, 5, the closed interval, and we have an absolute maximum at 5 here at this point, an absolute minimum at this point, 2, and we have a local maximum at 3 here, and local minimum at 2 and 4. So that's one solution to the problem.